Hello everyone. In this video on writing scripts, we'll be taking a look on how to create our own unexploitable shoving tool. First of all, if you want to see a detailed discussion on the unexploitable shoving algorithm itself, please watch the videos that I made on that earlier. They are linked to on the screen right now. For this video, we'll be using the range commands, which are highlighted on the screen right now. Let's now move to our tree. I've set up a spot where small blind is considering shoving or folding versus big blind. Now, of course, the software can already automatically figure this out for you with the unexploitable shoving tool. For that, just set a checkpoint at the decision where you want to shove or fold, and then press the all-in button. And there we are. However, the purpose of this video is to accomplish the exact same thing with the script. Let me just click the undo icon so we return to the original tree. So, how should we approach this? Given that in unexploitable shoving fill-in always makes a perfect call, let's start with that. If we would manually do this, then the steps that we would need to take are compute, mouse over the condition where you want to make a perfect call, and press Alt plus D to remove the -EV hands, and after that recompute. Okay, let's do this in a script. So we perform an EV run, then we remove the -EV hands, and then we perform an EV run again. And the delete command requires a location. We'll use location 2. Okay, so let's try that. I'll set location 2 at big blind's call condition. And I'll enter some range for small blind to shove with. For that, double click his racing condition. Enter the range and press done or enter. And now press the run button to let the script figure out the optimal response for big blind. Okay, let's try another range. And now run the script. Okay, something has gone wrong here. Big blind is calling with an extremely narrow range, while given small blind's wide shoving range, you would expect him to call much wider. The reason for this weird result is that when the script is started, big blind should be calling with all hands. So the script should read, reset to all hands, EV run, delete -EV hands, EV run. Now there is a script command to accomplish this. This command is the set all hands command here. I'll just drag it on top and apply it to location 2. And let's try that again. Let's enter a range. And I'll now run the script. And there we are. Big blind will now indeed pick the optimal response. And now, all that remains is to set up a loop around these 4 lines that vary small blind's racing range, and then measures the EV for each loop. First of all, I'll set small blind's race condition to the top variable 1% of hands. And now I'll set up a loop so that we can vary variable 1 from 0 to 100 with a step of 5. Now, I've already explained how to set up such a loop in the previous videos, so I won't go over it in too much detail again. At the start of the script, we'll set variable 1 at 0. After our instructions have been performed for variable 1, we'll increase it by 5. And if variable 1 is at most 100, we go back to line 2. And we end with an end if statement. And that's our loop. Also, at the end of each run, we'll add a data point. Again, I won't go over this in too much detail either. I've already discussed that in the video on creating graphs. Field 1 should be the value for variable 1. And in the second field, we'll retrieve the EV from the tree at location 1. And at the end of the script, we'll draw our graph and load the best performing tree to the screen. Okay, so let's test that. First, I'll set location 1, since the script needs to know where to measure the EV. And I'll run the script. And I'll just skip here. And there we are. Apparently the best performing tree we came across had an EV of $1.39, and we were shoving the top 45% of hands at that point. Let's have a look at that tree and compute. Okay, and let's now compare that result with the one that would have been found by the software's unexploitable shoving tool. So we already have a checkpoint here at the shove fault location, and I'll now press the all-in button. Okay, so the unexploitable shoving tool beats the $1.39 result from our script by 10 cents. However, since it's a simple script, it's still a pretty decent result. Now, the main reason why the unexploitable shoving algorithm performs quite noticeably better is because the top percentage we use for small blinds, and I'll just show that here, is not optimal for the shove or fold strategy. As it turns out, if you want optimal results for unexploitable strategies, you'll need to use hand rankings that are determined dynamically based on EV. However, that will be the subject for the next part of this video. For now, thanks for watching.